Hey everyone, today we're going to talk about what should be a relatively new topic. It's called significant figures, and I'm going to get right into it because we got a lot to cover. We use significant figures when we report measurements. So a lot of the times you're going to be measuring things, especially using glassware. I know we used beakers last time, and I gave you a sort of 50 milliliter reported answer. But here we're going to learn that measurements are really important and we have to be really careful when we report them. So some learning objectives, we want to understand how to accurately report measurements. We want to be able to count significant figures. If this word is new to you, there's basically rules for how many numbers we can put when we do a measurement. So, and those numbers will either be significant or not significant. Then we're going to add some math in there, just some addition and subtraction, multiplication and division. Make sure we know that when we're working with numbers, how to report them accurately. And then understand that this is going to be a continuous topic. So this is just an introduction for today. I'm going to expect that we understand and we can move forward and use this. And you're going to be responsible for knowing this, not only in this class, but in chemistry, where it becomes extremely, extremely important. So I wanted to start by saying how much water is in this graduated cylinder. It looks like this is about 10, 20. Of course, there are no units here on the picture that I have. Just another point proven on why units are important. But if this is 20 and this is 25, we can say that there's about 24, I'm just going to assume it's milliliters of water. Okay, so how much does this glassware contain? We want to look at the bottom of the meniscus. Again, this is something that you're going to learn in chemistry, but we're just going to talk about the sort of number aspect of it and why that's important. So we can say pretty confidently this is about 24 milliliters or 24 units of whatever is measuring this water. Now that was pretty simple to do, but what if we're given something like a beaker where pretty clear this is 20, this is 30, this is 40, and this is 50, and the water lies somewhere around here. How do we know exactly how much water is in there? Okay, and this brings us to our topic of significant figures and this sort of idea of accuracy, precision, and kind of uncertainty. We're actually unsure at this point. We know it's between 40 and 50, but we don't know if it's exactly 45, if it's 44, if it's 46, because our glassware is not labeled clear enough. So we have to be and use this term uncertainty. Okay, and uncertainty is a huge part of science. Again, this is really a chemistry topic. But because you guys are going to take chemistry next year, I want to do as much as I can to prepare you for that. And as a scientist, you are responsible for recognizing uncertainty in measurements. And you can do this by adding a plus minus after each uncertain measurement. If you are absolutely sure about a measurement, there's no need to add uncertainty. So again, we're going to look at this beaker in a second, once I pull it up. We're going to look at sort of lengths and volume and then identify the uncertainty that we see. So if we look here, we can see that this is somewhere between, I can't see on my iPad. This is somewhere between 2.7 and 2.8, okay? So we're between 2.7 and 2.8. So now we have to deal with this uncertainty. My best suggestion for you is to start with the lower number. So we know that it's above 2.7. So we're going to add a plus minus 0.1 to get us to 1.8 because we're certain that it's at least 2.7, but we're not certain that it's 2.8. And this goes to the same with volume here. If we're looking at this one down here, we can say, okay, we're between 60 and 65 for sure. So 60 is here, 65 is here. And it looks like we're above 64, but we're not certain about it. So my best suggestion is to start at 64 and go plus and minus 1, because we're for sure not certain that it's at 65. And then finally, just to do one more example, we can see here, this is at least 20. 1, 2, 3, 4, 25, somewhere between 25 and 26. So again, really simple. This volume is 25 plus or minus 1. Okay. And again, this is going to take some getting used to. It's a little bit weird to report a number like this or report a measurement like this, but this will save you from making some mistakes. Especially when we're getting, when our measurements have to be exact. Otherwise, we do the lab or we do the experiment wrong. And I'm going to go ahead and clear. So how does significant figures play into this? Well, significant figures are numbers, and each number is assigned a notation of significant or insignificant. And they are reliable. So the amount of significant figures tells you how accurate the measure is. So the smaller number of significant figures you have, the less accurate your measurement is. If you have a ton of significant figures in your final answer, that means that your answer is more exact, if that makes sense. And when we talk about significant figures, zeros and decimals become the most confusing part. And there's a list of rules I'm going to give you to understand why significant figures are important. So there are 5 rules of dealing with significant figures. All non-zero numbers are significant, whether they are before or after the decimal. All zeros between non-zero numbers are significant. So if there's a 0 between any 2 numbers, that 0 is considered significant. Leading zeros are insignificant. And I'm going to go into detail about this pretty soon. I'm going to give you guys a bunch of examples. Trailing zeros without a decimal are insignificant. So in any whole number, if that number doesn't have a decimal point, any trailing zeros are insignificant. And then zeros after the decimal point are only significant if they come after a non-zero number. And again, I'm going to show you examples of this. All non-zero numbers are significant. So we have here 4 non-zero numbers, 1999, 1999. This number has 4 significant figures. Any zeros between non-zero numbers are significant. So again, we have 3 non-zero numbers, 1, 9, and 9. But what about this 0 here? Is that significant? Absolutely. It is a 0 between 2 non-zero numbers. So this now has 4 significant figures. All 4 of these are significant. Leading zeros are insignificant. What does this mean? Sometimes you'll have numbers that are less than 1, which means that they are 0 point something, okay? All those leading zeros are insignificant. So here we have a 0, 1999, these are non-zeros, they are significant. But is this 0 significant? Absolutely not, because it is a leading 0. So this has 4 significant figures. Trailing zeros without a decimal point are insignificant. So again, we have 4 non-zero numbers. So we definitely have at least 4 significant figures, but we have this trailing 0. Now, if that trailing 0 had a decimal point, it would be significant. However, in this number, there is no decimal point afterwards. We still only have 4 significant figures because that 0 is insignificant. And finally, zeros after the decimal point are only significant if they come after a non-zero number. So here we go. Let's look at our non-zeros first. So we have at least two. These two zeros are what are known as leading zeros. So we know they're insignificant. But we also have a zero at the end. And we are just told that if the zero comes after a significant figure or a non-zero number, then that zero is significant. Okay. So now we have 1, 2, and we're going to consider this last zero significant because it comes after a non-zero number. So in this, we have 3 significant figures. Okay. So let's practice. 4 non-zero numbers here. We have 4 significant figures. 0.9090, 2 non-zero numbers, 2 zeros, but they come after significant figures. We have 4 here as well. I'm gonna clear really quick. 1.0006. Those zeros are in the middle of 2 non-zero numbers. So we have, I'm sorry, not 6, 5 significant figures here. I'm gonna move myself a little bit. 0.000008. All of these zeros are leading zeros, and we have 1 non-zero number. So we have 1 significant figure here. 2.990, 4 significant figures, 3 non-zero, 1 zero that comes afterwards. 7 is just 1 non-zero number, so it is 1 significant figure. 100, trailing zeros without a decimal point. Are those significant? No. So this also has 1 significant figure. 909, we have a 0 between 2 non-zero numbers, so that 0 is considered significant. So we have 3 significant figures. 9.0, although this 0 is after the decimal point, there's still a non-zero number in front of it. So this has 2 significant figures. 4.5 times 10 to the second. Okay, if we were to write this out, it would be 4,500. These two are the exact same numbers. We have 2 non-zero numbers, so it's at least 2 significant figures, and we have two trailing zeros, which are not significant. So anytime you have something in scientific notation, all you have to do is look at the first 2 numbers, and that will give you the number of significant figures. This one has 2. Again, same thing. 8.01 times 10 to the negative 7th. Doesn't matter how many exponents or what the exponent is. This is only going to have as many sig figs as here because all we're doing is adding zeros that are either going to be leading or trailing. So 8.01, 0 between 2 non-zero numbers. This has 3 significant figures. Oh, sorry, went by quickly. Anyways, we're going to do a lot of practice on this coming up. And we'll go over adding and subtracting significant figures in class next time. Okay. Have a fantastic weekend if you watch this, or I hope you had a fantastic weekend. I will see you guys soon.